alkynes and the main characteristics of them, we can say that are the thermologous series of organic compounds of hydrogen and carbon that are unsaturated hydrocarbons because they have at least one triple bond between the atoms in the molecules and have a general formula of CnH2n-2. In alkynes, the hybridization is simply sp, giving bond angles of 180 degrees. The simplest alkyne is the thine with a molecular formula of C2H2, commonly called acetylene, and is used in welding, where it reacts with oxygen to produce flames with temperatures above 3,300 degrees Celsius.
There are some easy steps to follow in order to name an alkene based on the UPAC rules. The first step is name the longest carbon chain that contains a triple bond. The second step is number the atoms starting from the one nearest to the triple bond. The third step and final is give the location and the name for each substituent as well as the location and the name for the triple bond. Well, now there are some examples that I'm gonna do to show how to apply these rules in naming an alkene. Well, in the first example, we first need to find the longest chain of carbon atoms that contain the triple bond. In this case, is this one. The second step is to number the carbon atoms starting from the one that is nearest to the triple bond. Here I located the longest chain of carbon atoms that is called the bond chain, and now you have to number in order starting from the one that is nearest to the triple bond. In this case it doesn't matter because there are only 4. So this is the number 1, the second, the third, and the fourth. Now you need to give the location of each substituent and name, and as well for the triple bond. In this case we don't have any alkyl group, so we're only going to locate the triple bond and the location and name using prefixes. Well, here the triple bond is in here. We do this, and this means that the triple bond belongs to number 2. And then we write the location, that is the number of the atom in the carbon atom where it is found, that is 2, and then a hyphen, and then like there are 4 carbon atoms, we put the prefix for 4. And the termination of alkene, that is ene. So this is called 2-butene. The next example has an alkyl group, so we will start again finding the bond chain that is here, 1, 2, 3 carbon atoms, the bond chain, and then we need to number and starting from the one that's nearest to the triple bond. So we start from here, 2 and 3 carbon atoms. Then we need to give the location for the substituent or alkyl group that is called methyl. So we need to give the location. It would be in the carbon 3, so we write 3 hyphen methyl. And then we need to locate the triple bond, that in this case would be from the carbon atom number 1. So hyphen 1, and then we write the prefix for number 3, that is prop, and the termination of an alkene, that is propene. So this is called 3-methyl 1-propene. The next example has no substituent, but it's the same. We need to find the bond chain, the the longest chain of carbon atoms, and then we need to number them starting from the one that is closest to the triple bond, but in this case there are 6, so it doesn't matter the order. I'm going to start from this side, from left to right. 6 carbon atoms, and then we have to give the location for the triple bond. In this case it will be from the carbon atom number 3, so we will write 3 hyphen, and the name of the prefix of this chain would be hexa, and then we write the termination of an alkyne, 3hexa.
Well, now we're going to see how to write the structural formula for our alkenes. As we can see in this case, we have this formula, which is 2-butene. What we have to do, first of all, to write the structural formula is to divide, in this case, the name in 3 parts. First, the ending in, which means that we have a triple bond, but which means we have 4 carbons, and the number 2, which indicates in which carbon is going to be found the triple bond. Well, first, but means we have 4 carbons, so what we're gonna do is to write 4 carbons. Then, in means that we have, or as I already said, a triple bond, and the number 2 indicates where is it going to be, so we number the carbons 1, 2, and in the number 2 we add a triple bond. Then, as we may know, carbons in this case have to have 4 bonds, so to complete them we just add single bonds between the other carbons and complete the 4 ones of each with hydrogens. As we can see, this is the finished compound. We have the triple bond here and hydrogens to complete all the 4 bonds on each carbon. Now we're going to move into some different examples. First of all, we have this one, 3-methyl 1-butene. As we can see here, we have methyl, which indicates that we have a branch into our parent chain. Again, we divide the number into different parts so it can be easier to write the structural formula. Again, first, the ending in, which means we have a triple bond, but which means we have 4 carbons, and number 2, which indicates where the triple bond is going to be found, methyl, which indicates that we have a methane alkyl group, and 3, which indicates where is the methyl going to be found. First, but means, as I already said, 4 carbons, so we write the 4 carbons. Then in the number 1 we have a triple bond, so we drop it. We have a methyl group which is going to be found in the carbon number 3, so we number the carbons 1, 2, 3, and in the number 3 we add a methyl. As we may know, methyl is a alkyl group with just 1 carbon, so we just write the carbon. And to finish off the compound, we just add single bonds between the carbons and finish them off with hydrogens. As you can see here, we have now the complete formula. Well, now for this example, as we can see, is really similar to the first one I already explained. The only thing that is different is the number of carbons that we are going to use. So again, we divide the name into different parts so it can be easier to write the structural formula. First, the ending in, the pent, which means I already said 5 carbons, and the number 2, which indicates the carbon number in which the triple bond is going to be found. So let's start. Pent means 5 carbons, so we just write the 5 carbons first. Then the number 2 indicates where the triple bond is going to be found, so we number them 1, 2, and in the 2 we add a triple carbon. Then to finish off the formula, we just add single bonds between the other carbons and finish each 4 bonds with hydrogens. I haven't explained this, but as we can see here, we have 1, 2, 3, which is the triple bond, and then this single bond completes the 4, so this carbon doesn't need any more hydrogen. As you can see here, we have now this finished formula. Well, now for this example, as we can see, now we have a bigger compound. It can look like difficult to write this, but it is actually pretty easy. The only thing that we need to do is, as I already explained with the other 3 examples, divide the name into different parts so it can be easier. First of all, the ending in, which indicates we have a triple bond, the prefix F, which means that we're going to use 7 carbons, the number 2, which indicates where the triple bond is going to be found, methyl, which indicates we have an alkyl group, number 5, which indicates the number of carbon in which the methyl is going to be found, chloro, which means we have a halogen, and the 4, which indicates where the halogen is going to be written. Now, first, we have, as I already said, a prefix "-ept", which means 7 carbons, so we just write 1, 2, 3, 4, 5, 6, 7. The number 2 indicates where the triple bond is going to be found, so we just number them 1, 2, and in the carbon number 2 we add a triple bond. Then we have a methyl in carbon number 5, so we just again number them 1, 2, 3, 4, 5, and in number 5 we add a methyl, which I already said is just a single carbon. And then the halogen, which is chloro, is found in carbon number 4. So since I already have numbered, I just found the carbon number 4 and write the halogen. Now, to finish this formula, we just have to add the single bonds between the carbons and finish each fourth one bonds with hydrogen. As you can see here, it's like really easy to write the formula. Either it is like very long or short. We just need to practice.
Hello, my name is Gustavo, and I'm going to talk about hydrocarbon derivative. Well, organic chemists classify chemical compounds according to their functional group. A functional group is a special arrangement of atoms that is mainly responsible for the chemical behavior of the molecule. Functional groups also determine some of the physical properties of the molecule. When one or more functional groups are attached to a hydrocarbon, the resulting compound is referred to a hydrocarbon derivative. Hydrocarbon derivatives are compounds made up of carbon atoms and at least one atom that is not hydrogen. So, hydrogen is an organic compound that contains only carbon and hydrogen in their molecules. Also, I want to share with you some examples of hydrocarbons derivative. Here, as you can see, we have some examples with the formula. Here we can see that it says alcohol, and here is the formula. Here are some examples of hydrocarbons. So I invite you to make conscience about the hydrocarbons and see in what we use it. Thank you.
Well, I found out very interesting how the UPAC contributes to the application of chemistry in humankind. The UPAC system advances chemistry. Why? Because it is part in the setting of symbols, names, and units. The UPAC system also evitates any kind of confusion, and scientists speak in the same language, and they together can create very useful things that serve in the advance of humankind.
Are one of the most important substances in our life due to all the uses that we give to them. Anyway, they are also a big cause for all the pollution problems that we are causing. The main cause is that we use them as fuels, and when we use them as that, they release greenhouse gases, which at long term increase the global warming and affect the climate change. Also, at short term, these gases produce health problems in lungs and heart of children and adults around the world. Another big important thing about hydrocarbons is the nomenclature, because thanks to it, we can identify substances that we use in our daily life, such as medicines, to determine whether if they are okay for what we're using it or not.
I learned a lot of things in this tutorial video and the research previous to it. I think that hydrocarbons and petroleum and its derivatives are very important for our society. They are essential essential because carbon-containing compounds are everywhere, also in our bodies and nature, but they have caused serious damages to our environment. Some examples are like indirect and direct. The indirect examples would be like when you burn things and they produce gases that contaminate air and they can cause sickness to people. Also, another direct way in which hydrocarbons contaminate and damage our environment are oil spills, in which petroleum is all over the ocean because of accidents, and they contaminate water and also marine life, and it is very harmful and it's very difficult to repair the damage in the environment. And there are many things that damage, like also fertilizers that made with hydrocarbons. They damage plant life and they also contaminate soil, and they can damage our health because we eat the things that come out from our crops. And there are many ways in which hydrocarbons and its derivatives damage our environment, so it is important to look for other clean sources of energy, like for transportation and electricity, because even though they are very important, they can be.
So my reflection about this is that we use hydrocarbons in all the time. We make plastics, lubricants, paints, textiles, medicine, and also we use it to make some electricity.
Hi again. As a conclusion, I think that this topic is very important on chemistry and was very interesting for me. At the beginning, I didn't understand all the topic and was some harder for me, but I read more and put more attention, and then I could comprehend the great topic that is organic chemistry. As the teacher said, know about this topic can be helpful in the future if we want to study engineering. Sorry, something important to know for me because I want this.